In this video, I'll use publicly available Ashkenazi Jewish trio data from Genome in a Bottle to investigate an imaginary mystery illness using GenVision Pro's variant filtering workflow. Imagine that a teen boy has fevers and inflammation on a recurrent basis, but neither parent has ever had these symptoms themselves. Could the boy have inherited deleterious recessive genes from both parents? To test this hypothesis, I started by downloading exome data for the trio from Genome in a Bottle. Next, I used SeqManEngine to make an assembly and call variants for each member of the trio. I knew I wanted to have an enriched set of annotations associated with these variants, so when I set up these assemblies in the Setup Wizard, I made two specific choices. First, I specified that the reference sequence be one of the human genome template packages from DNASTAR, and second, I checked the box for the variant annotation database. The final step, which is the focus of this video, is to load the assemblies into GenVision Pro and filter to find variants of interest. After filtering down to these variants, I'll explore them further using integrated links to Genomenon's Mastermind database and NCBI's ClinVar database. Once assembly was finished, I uploaded all three assemblies to GenVision Pro. I'll start by creating a default variants table using variants, show table with default filter. Among the three subjects, over 660,000 variants were located. Obviously, these variants will need to be filtered before we can find any variants of interest. The first thing I'm going to do is use GenVision Pro's advanced variant filtering functionality to find the heterozygous variants that are shared by the two parents. To do this, I'll choose Variants, Filter, Filter, and then I'll make changes to several of the tabs that you see here on the left. In this first tab, the Experiments tab, I will select Present in All Selected Experiments, and then I will choose the two parents. In the Type tab, I want to choose only heterozygous SNPs, and in the Impact tab, I only want to choose non-synonymous SNPs. I'll press Apply and then Close. Looking at the blue bar here, we can see that we have now filtered down to just under 3,000 variant locations. We want to save this set, so I'll use Variants, Create Set of 2,978 variant locations, and I will call this one Heterozygous Variants in Both Parents. And next I want to find the homozygous variants in the son. I'm going to use a similar technique to what I used previously. So I'll start by choosing Variants, Filter, Filter. This time I'm going to go to Experiment, and instead of the parents, I will only check the son. And in Type, I want it to be homozygous this time. And Impact will leave the same with just the non-synonymous SNPs checked. And again, I'll press Apply and then Close. So here, GenVision Pro has filtered down to 4,500 locations that are homozygous in the son. Again, I'm going to save this as a set, which I'll call homozygous variants in the son. So the final step is to find out which variants are in common in both of the sets that I just saved. In the variant sets section here, I'm going to select both of these, and then I'll right-click and say Create Set of Variants using a Venn diagram for those two variant filter sets. And then I simply click on the intersection between those two sets to find the variants that are in common between them and press OK. So now we've filtered down these variants, so there are just 534 variant locations of interest. But which of these variants might be responsible for the fevers and inflammation? We'll have to do a little bit more investigating to find that out. I'll click on this gear icon, which is the Choose or Rearrange Columns tool, and then Settings, and I want to look for pathogenic variants. So I'll open up the ClinVar traits a little bit further and add one for the sun. And then up here, I'll open up the Mastermind, and then Mastermind count 3, I'll add the sun and the sun there. So that's ClinVar trait, and then 2 columns that have to do with the Mastermind database. and then I'll press OK to add those columns. I'll click one of these mastermind column headers to bring all of the entries with mastermind citations to the top. And we can see here that there are a couple that have a lot of citations. There's one with 546 citations and one with 487. We can already see this is familial Mediterranean fever, so that sounds like definitely something that we should look into. If we take a closer look at the row for this particular SNP, we can see that each of the parents has one copy of the normal G base at this position and one copy of an A variant, whereas the son has 2 copies of the A variant. If we want to check this other one, we can click on its link to go to its mastermind entry. And this has to do with bitter taste receptors, so that's probably not going to be of interest to us. So let's go to this entry for the familial Mediterranean fever. And here we can go to some articles that talk about this variant, and we can click on any of these articles to read more about the correlation between this particular variant and the familial Mediterranean fever, or we can go to view it in ClinVar. You may note that the classification is benign. I'm not sure why this is, but there are many known deleterious variants that are still classified by ClinVar as benign. But if we scroll down here, we can see that the conditions that it's associated with include familial Mediterranean fever, as well as an autoinflammatory syndrome.